Normal distribution, reverse exercises. When a process or outcome is considered to be normally distributed, you can be given a probability, often written as a percent, and asked to find the value of interest A, which makes a probability statement true. For example, the probability that X is larger than A equals 0.90 for what value of A? Let's look at an example. Suppose the amount of hours worked per week for full-time students follows a normal distribution with a mean of 20 hours and a standard deviation of 4.5 hours. Let X be the hours worked per week. 90% of all students work less than how many hours per week? Begin with what you know about a normal distribution. First, begin with a sketch. Draw your normal or bell curve, label the mean and the common edges, those that are 3 standard deviations above and below the mean. You can also label the z-score scale where the mean is 0 and the common edges are -3 on the left and +3 on the right. First, determine if the value you're trying to find is to the left of the mean or to the right of the mean. This depends on what is being measured and logic related to the variable. Since Table Z always gives the area to the left of the z-score you use, eventually you start with finding the z-score, then the equivalent value for the variable. So the graph of the normal curve to find our value of A, remember we were told the amount of hours worked per week for full-time students was distributed as a normal random variable with a mean of 20, so we label the center, the peak, at 20 hours and a standard deviation of 4.5. So we could go 3 times 4.5 or 13.5, and if we were sketching by hand, we would add and subtract that 13.5 from 20 and label those edges. Now find A such that the probability that X is less than A is 0.90, and that just comes from 90%. So the location of A has to be to the right of the mean so that 90% of the area can be to its left, because we want the value of A to have 90% of values less than it. Now remember, we're going to actually start in the Z distribution as far as getting our numbers. So what we want is really the probability that Z is less than some other letter B is 0.90. Notice that B is the value in terms of z-scores, while A was the value in terms of the original X variable. We must recognize that this value will be above the mean. Recall that you know half or 50% of the area is to the left of 0 in a Z distribution. So we need the value B that has 90% or 0.9000 as the area to its left. Look for 0.9000 in Table Z as an area. That's one of the 4-digit numbers. Get as close as possible. If 2 values are equally close, we will probably just take the average of the 2 z-scores. So which value is closest to 0.900 in Table Z? Or graphically, let's look at what we're finding. So if the red part is the 0.9000, then we're finding the probability Z is less than B is 0.9. And again, B is the value in terms of the z-score, while in the previous graph, A was the value in terms of the original X variable. Now you can see below I already have B labeled as 1.28. How did I find that? Well, finding B using Table Z means I want to look for the value, so the probability Z is less than B is 0.9000, or as close as I can get. And looking in the standard normal probabilities table, or table Z, the closest value I can get is 0.8997. Now if you read across the row, you can see the row has Z for 1.2, and go up the column where 0.8997 is located, and you get the hundredths digit of 8. So 1.2 for the tenths part, 0.08 for the hundredths part gives you the 1.28. Just to review, the closest area value to 0.9000 is 0.8997. Now look at the z-score for the area of 0.8997. The row is 1.2 and the column is 0.08. So putting that together, z equals 1.28. Again, we know this is to the right of the mean, so it will be positive. In terms of z-scores, the value of interest is 1.28. In terms of the original x variable, what is the value? You can solve the z-score equation for x, and what would you get? Remember, z equals x minus mu over sigma. Algebraically, you would multiply by the standard deviation on both sides, so you would get z times sigma equals x minus mu. Then you would add the mean mu to both sides. So you end up with x equals mu plus z times sigma. You found that x equals mu plus z times sigma. Recall that z is 1.28, the mean is 20 hours, and the standard deviation is 4.5 hours. Now substitute into the equation. So x equals 20 plus 1.28 times 4.5. Do the multiplication, 1.28 times 4.5, then add that number to 20 to get 25.76, and the units are hours. So about 90% of full-time students work less than 25.76 hours per week. The only issue is whether the z-score should be positive, as it was in this example, or negative. You have to draw the normal curve, label the mean, and figure out whether the value of interest should be above the mean or below the mean. And that is more logic. So for these backward or reverse exercises, these are the steps. Draw and label your normal curve and figure out whether the value of interest is above or below the mean. If it's above the mean, you're looking for a positive z-score. If it's below the mean, you're looking for a negative z-score. Convert the graph into a z-curve. Just label the mean as 0. Find the appropriate area to the left of that location, and then use table Z to get the z-score of interest. We called this B in our example. Then solve using the equation x equals mu plus z times sigma. Now if z is negative, you're going to have the mean minus some value, because when you take the negative z-score times the standard deviation, you'll have a negative result. So adding a negative is like subtracting the number. Just make sure that the value you're looking for is to the left of the original mean, if that's where you drew it on your graph, or to the right of the mean, if that's where you drew it. And be sure to summarize the results in a complete sentence.